Now I'm working. So today, how do we do it? So 5, 3, 22. Today what we're going to do is we're going to prove a quadrilateral. That's a four-sided figure. Quadrilateral is a parallelogram. I'm going to do it by our theorems, prove parallel by our theorems, and our theorems are these theorems here. And it's easier if we just take a look at how they have them here. So these are the ones we're going to use. If our parallelograms have any of these 5 characteristics, it's going to be a parallelogram. So, all right, let me go ahead and draw some pictures because it's just easier to see. So our first condition is, draw a picture. Our first condition is simply this, and I'm going to mark my figure. If we have this, you remember what the little arrows represent? You guys remember that from yesterday? So if opposite sides are parallel, it's a parallelogram, right? You guys agree with that? The second case that our theorems give us if it looks like this, then we know that if opposite sides are congruent or equal, same word, congruent, equal, same thing. Why don't we just use equal instead of congruent? Well, there's a reason. Okay, so if opposite sides are equal, it is a parallelogram. Third condition we've seen, these are conditions we already know, is this. If you know opposite angles are equal, it's a parallelogram. Am I going too fast? Let me slow down for a second. I'll slow down for a second, okay? So we've got 3 of the 5, and we know these. All right, let's look at the 4th one. I want these in my notes so I can use these later. It's nice to have in my notes. Okay, this is a new one. So if one set is both parallel and equal. So if we've got one pair of opposite sides are parallel and congruent. I'm going to put a star by that one because that's kind of a new one. Then it's got to be a parallelogram. Has to be. And then finally, the 5th one is about the diagonals. So the 5th way we can prove these is to look at the diagonals. I'm going to draw my diagonals in here like this. Here's my diagonals. There's my diagonals. If they bisect each other, which means they cut each other in half, that's equal to that, and that's equal to that. So if diagonals bisect each other, meaning if this piece is equal to that piece, same length, if this piece is equal to that piece, same length, then we can say they're equal. So if diagonals, diagonals, come on, Bill. Get ahead of myself. Diagonals bisect each other, then we know it's got to be a parallelogram. Okay, so those are the 5 ways we're going to prove something. And we just need to show that and then write a statement. Okay, so how does this work? I'll show you. We're gonna look at it. We're going to look for one of these, and then we're going to state it. Okay, so let's go ahead. Example 1. I'm going to graph it first. I'll go -3, 3, 4, point A. Stop me if I get going too fast, okay? 2, 5, 1, 2, 3, 4, 5 for B. 5, 2, 1, 2, 3, 4, 5, 2 for C, and 0, 0 for D. Okay, let me go ahead and graph it in, okay? Nope, a little bit too long there. It's all right, it'll work. Yeah, it'll work. All right, so just looking at this picture, just looking at it, is it a parallelogram? Looks like it, but how can we prove it? It looks like it is. Well, we could do a lot of these, okay? We could measure the angles, but that means I got to get my protractor out, right? I could measure, what's it? We could find the lengths of the sides. We could measure that, right? What do you think? That's the easiest way. Now, all of those are correct, but I agree with Miles. The easiest are the slopes, because I can just count the slopes, right? So what's the slope of AB? Well, I'm just going to count it. It's going to be up 1, 2 over 1, 2, 3, 4, 5. So then what's the slope of DC? Well, I'm just going to count it. Slope, right? Rise. Slope is always rise over run. Slope. So DC, I'm going to go up 1, 2, 1, 2, 3, 4, 5. Up to a 5. So I already know that AB is parallel to DC. I know that. I know that because they have the same slope. Thanks, Miles. It's a great guess. How about A to D? Let's figure out AD. What's the slope of AD? Down 1, 2, 3, 1, 2, 3. Down 3 over 3, which same thing as 1 over 1 or -1. And what's the slope of BC? Well, let's count it. Down 1, 2, 3, 1, 2, 3. Same slope. So I can say that AD is parallel to BC. So finally, I know. I'm going to say this. I'm going to say that this parallelogram or quadrilateral ABCD is a parallelogram. Oh, my pen's going to die on me. Of course it is. Is a parallelogram. Do I have a different pen somewhere? Oh, I got a green one. That would look weird, huh? Is a parallelogram. Look at that. Pen's dying on me right there. I got another pen. Okay. It is a parallelogram because opposite sides are parallel, right? Opposite sides. I'm running out of room. Parallel. I'm running out of room. Okay, I proved it, didn't I? Okay, so I just had to prove it and then make a statement. Okay, I'll say it again. I got to prove it. I got to show my evidence. So I have to have some evidence. Here's my evidence. I proved it, and I have to make a statement. So kind of like being in court, right? Your Honor, guilty. It's a parallelogram. Here's my evidence. Opposite sides are parallel. So my statement is, Your Honor, it is a parallelogram. See how it works? I have to go through and show my evidence, and then I have to make my statement to the judge, and I prove it's a parallelogram. Okay? You guys ready to turn the page? All right, let's take a look at example 1. Now, so if it's a parallelogram, what values of x would make this a parallelogram? So what I want to do is this. Find the value of x that makes it a parallelogram. So I know these two angles are probably going to have to be supplementary. So the first thing I'm going to do is say 3x minus 20 plus x plus 40 equals 180. Okay, I know they're supposed to be supplementary. So I want to make it. I'm going to make it into parallelogram, okay? So I said, okay, this angle plus this angle, they're adjacent angles, have to add up to 180. So I get 4x plus 20 equals 180. Okay, I'm just solving. So what I want to do is make it a parallelogram. What value of x would make it a parallelogram? So then, minus 20, 4x 160. Divide by 4. X is 40, right? So if x is 40, then I know this is going to be 80 degrees, and then this one is going to have to be 100 degrees, okay? And if that's the case, I can find the value of y. The value of y, okay, if these opposite angles have to be equal, I can just say, okay, 4y has to equal 100. If I divide by 4, I get y equals 25. So if, here's what I'm going to say, if x is 40 and if y is 25, it must be a parallelogram. It has to be, right? I'm forcing it. It should make opposite angles equal, and it would make adjacent angles supplementary. All right, here we go. Example 2. I know they're parallel, but if these two sides are equal, I got it. So let's make these two sides equal. How can I make them equal? Let's set them equal and find the value of x, okay? So I can go 10x plus 7 equals 12x minus 9. So what I want to do is find the value of x that forces them to be equal. So let's find the value of x. All right, minus 10x minus 10x. 7 is equal to a 2x minus 9, right? Plus 9 plus 9. 16 equals 2x. Divide by 2, x is 8. Okay, if x is 8, this side is 87, and this side's 87. So they have to be, it has to be a parallelogram because of a parallel sides and equal sides. And the last thing, y must be 106 because opposite angles are equal, so y's got to also be 106.
Interruption. Next year's seniors, class of 2023, your last name starts with Q through Z. Please report to the Commons with a computer for scheduling.
Okay.
Again, last name starts with Q through Z. Report to the Commons with a computer for scheduling.
Okay, last example. Here we go. So, if I can make the diagonals equal, then they're bisected. If I can make the diagonals equal, they're bisected. So let's make them equal. Let's go 6x is equal to 4x plus 10 minus 4x minus 4x. I'll get a 2x equals 10. Divide by 2, x is 5. So if x is 5, that's going to make this side 30 and this side 30. Okay, 30, 30, they're equal. I like that. Now I need the other diagonal, so I'm going to do the same thing. I'll say, all right, well, what if 2y is equal to y plus 1? And I go minus y minus y. I've got a 1y equals 1. So y has to be 1. If that's the case, then this side is 2, and this side's also 2. So therefore, it has to be a parallelogram. I force it to because diagonals are equal, where they bisect each other. Okay? All right, that's all I have. Pretty easy? What do you think? Pretty easy? I think you guys are going to enjoy doing this a lot more than some of the other stuff. Geometry's easy. Should be. Stop recording. Stop. Stop.